How's everybody doing? We're doing some pulse motor art. We got the spiral. I wanted to say downward, but I think if it was downward, I would start from the outside and work my way in. But I started from the inside, worked my way out, so I was saying the outward spiral. I think it looks awesome. Very cool, very cool. And what this is a pulse motor. You got a trifecta coil here, 333 turns. 0.3 turns, 333.3 turns. My bad. Plus the ends. So that's probably another turn and a half or so. Hall effect sensor for the switch. And that's it. We're working on 5 volts, less than 100 milliamps. So that's like way less than a watt. Like, this is pretty dope for that. I would say this little coil is a beast. It's got a lot of torque to it too. Goes a little bit slower. I can't even get it up to full speed, I don't think. This one over here is all 32 gauge. Same amount of turns, 333.3. And this one is 132 gauge and 226 gauge strands. The 26 gauge strands I got wrapped in series. So it's only 2 connections to this instead of 3. You can hear that. I think that's pretty good. It's not exactly magnet, not exactly on the magnet. It's a little offset. Still a little offset, I would imagine. But it didn't have to buck like that. That was too much jerk in there. So what I'm working on in the back is another coil. That's like almost exactly the size of the magnet itself. And it's, if you put it, you could put a square around it. It's 45 millimeters by 45 millimeters radial, so you know it's just like all these other coils. But each time I wrap one, it's different. Just like each time I do a video, it's different. But it looks the same because they're all wrapped. They all look the same. Like this. But the last time I did a video, I had that coil hooked up here, connected to this. And so, you know, this is different. Now, I've done this already before, but I had a switch, the mechanical switch, didn't have the Hall effect. This is working way better. It's way better. We're at 6.5 volts right now. So It sounds like the farther away it gets from the coil. No, there's definitely a happy place there. Yeah. All right, here we go. All right, that's cool. So what we've been trying to do recently is use this coil right here to generate electricity to run this pulse motor over here. And it hasn't been working. I don't know what I'm doing wrong here. It's just a DC motor, right? All right, we're gonna get a DC reading, voltage reading real quick. Just real fast. And I always have my positive end be where the coil started. So your starting end. Positive is hooked up. All right, that's good. And then negative. Just gonna plug it in the other side of this. Wow, man, I'm shaking a lot worse than I usually do. So that's about 30 volts of DC. Get those caps up.
Got it.
At, we're putting in 6.46. But, I don't think there's any way to really correct the issue. But this is a little bit more, like I said, it has a little bit more kick to it because of the 26 gauge than the all 32 gauge one. So I'm going to just turn it up here a little bit. See if we can't get out of it real quick. Oh God. Oh boy. There we go.
Oh, we just got a like. Thank you.
Uh-huh. Thank you. Oh, look at that. Okay, we don't want to go that way. That sounds right. That sounds really good. All right. We're getting 52 DC volts now. 53. And yeah, about the place being so well loved here, we're gonna be cleaning it up really thoroughly in the next week or so, and moving, consolidating, not moving from the house, but more people will be moving in, so need to make room for them. Well, I'm not gonna discontinue working on stuff, but I'm gonna. Something that was shimmied into.
Yeah, I heard that. Down. Down, gear, downshift.
Yeah, that's weird. I think it's because of the vibrations. Some wires started touching, but I'm not exactly sure that's what's going on. Maybe. I still think that's awesome. I think the spiral on the top of this thing is pretty awesome too. Kind of looks like it's really different. Very cool. 56. I wanted to go all the way up with it, but it looks like it's going to be difficult to do that. That's 25 volts. What are we working with here, bro? You can do the math real quick?
Well, let's see. 4.8?
4.8 volts?
Yeah.
Or watts?
Watts.
Yeah. Okay, we're getting up there in the wattage.
Mike does.
Hey, Mike.
Sometimes bad transistors will function and spin the wheel, but it will make you think your bearings are bad or your wheel balance is off when it's just a bad switch.
Yeah, I totally agree with that. I've been switching the switches out all day, and it's been actually improving for a little while, and then like just now, something happened, and it stopped functioning at 100%.
I think his transistor skill is getting better. I do.
Awesome.
You know, when you're adding new tools to repertoire.
Yeah, I love how it runs so smoothly. I mean, my homemade switch cannot not get to this frequency. It's way lower.
Right. When did this one come in? Have you had this one forever?
This rotor or the switch?
Switch.
Yeah, I've had numerous ones of these since I started, and I've only got them to work since I started working with transistors.
Okay.
I used to hook them up, the base into the negative output or into the ground so that it would work like a switch, and it never really did because I don't think that's what happens. It just makes the light blink.
Here we go. I think this is exactly what's going on. I think you've identified it too. If you touch a transistor that is not isolated on its collector, and you touch the collector like that, when it's running, you will fry the switch.
Gotcha.
And then you can touch the collector while running so long as it's insulated from the heat sink with mica. There we go.
Yeah, I remember that.
Heat sink cannot be grounded. All right.
Okay.
We have yet to procure the mica insulated transistors, but we will.
No, that's probably a good idea. I mean, probably the next thing I need to buy will be the mica itself, or ones that have already been.
Yeah, probably both. Yeah.
Yeah.
Learn. Buy pre-made so we can get it going.
60 volts, AC, 58. Starting to rock the boat here.
See if I can get
About
that in
5 volts, or 5 watts, I mean.
You can kind of see it. Shake the table shaking. So yeah, we'll get it. We're gonna have a sturdier foundation here in the next couple weeks.
So I'm going to cut this. And I'm going to swap out. This transistor is working with the series 26 set series over here, and this one's working with the single strand 32. So I'm thinking that that was the. Well, I'm just gonna do both of them. See, and we got this EMF or whatever the back cycle is. The power supply is off. We still got 4 volts pumping through here. It's off.
Nice.
Gotta unplug it to get it any more off. I mean, like if I unplug all this stuff, it'll go down a lot faster because it's the coil that's doing it. But my buddy said I get readings like that when I hooked it up right, and there it is. Now, see, what I want to do is I want to get the electricity from here to spin this one with. I don't know what coil I'll use eventually, but hopefully I'll get one that'll work. And spin this one with the power from this. Now, a buddy of mine said that isn't going to happen because it's not motor ready. And I don't know if that's right, man. I don't know.
Mike Judge says they have insulator for the other types of transistors as well, so all of them can probably be insulated.
Okay.
All right, let's check out some transistor skill.
All right. Let me stop this. Wow, man, I'm shaking pretty bad today, so we're gonna take out that one.
He normally shakes like he's had like 5 cups of coffee.
And then this one is for the series. Oh, yeah, that looks good. God dang! Well, he's in the wrong field, guys. He's in the wrong field. This isn't. I can't watch that.
I might be able to help in the future. We'll see. Or maybe, all right, Mike says, right there, if there was power when he removed it, it will keep running, but not 100%. So that was when we were putting it on there. Okay. And then even power in a cap attached to the circuit will fry it. even if the plug is removed from the wall. Got it. So any kind of flow going through. Interesting.
Yeah, this is right. He was right. It was a switch that the transistor switch that was blown. This is way.
Residual power. Yeah. So that's kind of
This is way better. Switching out the transistors, making sure that the power wasn't it's still going through there. And because yeah, the residual power that he was talking about on here
yep.
was still flowing through the system. That's why I stopped the rotor.
But now you have turned it up to 5 point.
Yes.
Okay.
This is fresh. I'm turning this up from 0. And it's way more responsive. Yeah, wow. And you notice how it's not kicking like it was? Not even a little bit. I mean, it is only at 5. Maybe a little bit. You can feel that. Wow, that's really strong, actually, in my opinion. Because this glue that's holding it down, so I mean, like if it gets any stronger than that, I mean, it can get stronger than that, but I mean, like, that's awesome.
I know I'm right. It happened to me over 100 times. It's a pain in the ass. I never waste time making NPN circuit without insulating the collector. And then he said, correct. The kick is the indicator of bad switch, especially if you don't hear it when manual spinning with power off.
What happened here? Oh, yeah, it's not going very fast anymore. The DC voltage is going awry.
Thumbs up.
All right. Should we see if we can go up at all?
Yeah.
We'll do a 9-volt test. Oh, we're drawing amps.
You can hear it. 9-volt battery test. Oh yeah, it's drawing amps.
That's a strong kick. It's not shaking like it was, though. That's good.
See the wire strands vibrating.
I don't know. Something feels a little off, though. Maybe it's the switch or the Hall effect sensor. I mean, in its position. Sounds a lot better. It's perfectly on 9 volts.
Yeah. Sounds great.
Now we're going to do 12-volt tests. That's the battery packs I work with. Or 12-volt tests, 12-volt batteries, rechargeables. Ah, it's so smooth, man. I like it. I like it. And that's just putting a bunch of threes together, wrapping it up in a coil, and wow, bam.
Well, blam!
Yeah, the generator coils are going to be 3,333.3 turns.
Nice.
And they're going to be, oh, there's just, I hope it works out the way I think it will.
What are you thinking it will work out as? Like,
Maximum efficiency.
I like the sound of that. I like the sound of that.
It's got a perfect hole for a core that I have. And I can make, it's a single strand coil
Mm-hmm.
of the amount that I gave in turns.
3,333.3.
Exactly. 0.3.
That's a lot of threes. I like how many threes that is.
Yeah.
That's
me
6
too.
threes. No way.
5.
5 threes.
4 and 0.3.
That's right.
Yeah, that's epic. Oh man. So what we're gonna do is we're gonna take this top piece of we're gonna take this off, this top piece, because it's devastated. A little bit of the bottom piece is devastated, but we have 2 more pieces that are congruent with the bottom piece on the wall. We're gonna put a fresh piece on, but we're gonna have this whole thing be on the ground.
Yeah, better so there's no shaking. Everything's shaking. The whole house is shaking right now.
The airstream.
There's three.
62 volts for 12 volts in, 63 out. But like I said, this electricity, we can't use it to do anything that I've been able to do. You know, I tried to run this thing with it. I even had like 2 different switches hooked up to it. It looks like it would work good on its own. Like if I hook the wires in the coil together the right way. Because I know it would short circuit, but we're not trying to get like power out of it. We're just trying to
I get it now.
coax it along.
Mm-hmm.
Make, you know, one man into 100, one finger into 100. Something like that. So it'll keep going, but just because there's enough electricity going through this thing from this.
I didn't catch that. What was it from?
This right here
Okay.
has enough electricity going through it for me just spinning it like that.
Right.
And if I wind it together the right way, it's a 4-filer coil. Will it continue to run just with that? I don't know what the right way would be, if there is a right way. But that thing is, it wants to move. Look at how like smooth that is. That is very smooth.
Yeah. Barely a finger flick.
I think that the experimenting with just, you know, fascination and numbers, numerology even, looking up what these numbers mean. 3 is really cool. So it goes one strand, 2 strands, 3 strands. And when you, even though the last 2 are hooked together, that's still 2 strands. So it's like all together it's 3, there's 2, and then there's 1 that's separate from all the other ones. But when you put the power into it at the same time, because it's in the same coil.
You gotta look at the camera, bro.
Oh, I'm sorry. I'm sorry.
Mm-hmm.
Yeah, that's my bad. Okay. Well, I'll work on doing that. And
It's all good.
I'm sorry if I haven't been. I've been trying
Well,
to concentrate.
you've been doing good, but you've been looking me in the eye. You gotta look right down the barrel. There it is. There it is. Yep, you got it.
All right, we got that. That's that's good. So, anybody got any opinions on that? Like, I'm gonna do it, but I don't know if it's gonna work. Anybody having any opinions? But if that's gonna work, um, yeah, I think that it's gonna. I don't know. Actually, I really want to just try it because I've seen this invention on YouTube just a little while ago. Um, it was really awesome, and it was about using several conductors to basically make a battery that was in the shape of a coil, and it was awesome because it was a coil, and you could really like it was aw- it was really awesome. I thought it was a great invention, a great replica of another invention. It was really awesome, and I was thinking about how that worked, and could we utilize that same principle with this, except do it a different way, so that we didn't have to. I mean, using the same idea, but changing everything that doesn't have to be constant to fit our parameters. Like the parameters would be how far the rotor is away from the edge of this thing. You know, I don't want a lot of stuff sticking off the edge of it. So that's how big the coil's got to be. I like it. The radial shape is good. It was a radial coil. Use salt water. If anybody's seen this, it's a Daniel's invention. He remade the coil. I forget the guy who, Newton or something. The name of the guy who made the coil the first time, he said it was an old invention. I forget the name, but it was really awesome. I just want to give credit where credit's due, and
Kind of pointing in the direction. That's okay.
yeah. Especially if that is what's going to happen with this, I definitely want to throw a like, basically, and then
Like and subscribe. Hit him up on his Patreon
right.
or her. I'm not exactly sure.
Yeah, it's him.
Okay.
Yeah. That was really cool. And I'm like, yeah, that's exactly what I'm talking about. So you don't need a battery. You just kind of make your own battery. Um, yeah, that's awesome. Using salt water and cotton string and aluminum and copper wire. I think it was those three.
So you MacGyver.
MacGyvered it.
You MacGyver it.
Well, yeah. Well, I'm gonna take that. That's real science right there.
Yeah.
And I'm gonna take that science and I'm gonna MacGyver it.
You just said you need some toothpaste, a toothpick, a bubblegum wrapper, and some something else. No, I'm just playing.
No, that's right. That's right. I can do it all with a Tic Tac, man.
Yeah.
All depends. Yeah.
No, I like it. I like it, though. I like that idea.
All right, here, man. God, it spins so. I love it when a rotor spins the right way.
Yeah.
Nice and smooth.
Yeah, that is.
Nice and smooth. And we got one more that spins nice and smooth. Everything else
That one right there.
is
That one flips and flops. That one's all floppy. That one flops.
The one that's flat over there with the square magnets, the thing that's wrong about that is that one of those holes is 1 millimeter too close to the center.
Oh yeah, that's right. So it's off.
The weight's off by just that much, and that's enough. That's enough. It's literally enough to make it go boom, boom, boom when it gets going real fast. So when it ends up like this, it's like, yeah, that's a win. And yeah, I can only get my hands right now on a little 1/8 inch acrylic sheet size, so I end up gluing a bunch of them together. And these are nice too. They work when they get together nice. They work really good. And you can just, and then
Show it from the side. See how they're glued together?
yeah. But this, I mean, you can attach this one right to the shaft, and then the shaft will spin. I used to do it that way. I used to have the shaft spin. Put that wooden one over there running the fan. 66. 66. So that's steady at like 66.
Yeah.
With a 12-volt in, it took a while to get to 66, but that's all right.
There's the lev.
Oh, the magnet underneath.
Yeah.
That's, in my mind, that's part of the reason why it spins the way it does. Is it's a key. It's key. One of the key components to how this thing works is to have it elevated on the magnet using repulsion. 15.6 and 0.1 on the amps. That's going to be 1.56 watts.
That's right.
That's crazy fast, dude. That's insane. I bet this 4-fiber coil, if I could get it to stop overheating, could do about this.
Yep. It is pulling it. It's there it goes, yeah. So 1.56.
Yeah, when it gets going with the speed, it just, there it goes. But, you know, it'll come and go. Wow, that's so neat. I was having trouble with this the other day, but this is so much more satisfying than having trouble.
Okay, so when you got the 0.1, that's 100 milliamps.
Yep,
Yeah.
100 milliamps. But then that is 1.5 watts, correct?
Yep.
Yeah. Because there was this, I forget the name of the channel, but they were going through several coils, like from like this size and bigger to this size right here, the 4-fiber coil. They said this one goes 758 RPMs per watt. And everything else on the table didn't even come close to that. So I'm like, oh wow, yeah, I gotta try that. It works kind of good, but it gets really, really hot, really, really fast.
All right, Mike says anytime there's an issue, assume a bad transistor.
Assume it right off the bat.
Right after you verify the power supply is good.
All right, that's gonna make my life easier. I think that's awesome. Should I hook a transistor up to this baby one and run it normally with a Hall effect sensor, its own Hall effect? Run the profiler through a transistor and have it be powered by this coil right here, the big coil.
All right, before you ask that, you can always use a super high amp transistor this way. You can forget about bad transistors happening.
Super high amp transistor. I have, I forget where I'm putting it. It might be up there, but I have some MOSFET transistors that I just got in the mail. They're 49 amp transistors.
Those high amp NPN are not cheap, so you definitely want to insulate the collector before power up.
Yeah, I haven't even opened them yet. So yeah, I should probably get the insulator first before I do that.
Yeah.
Okay. And then I got PNPs right here. But I mean, you get no voltage off of these ones, so you can't get any speed really. Or I haven't been able to do it. I don't know exactly what the rate on the PNPs are, because the amps start kicking in around 3 volts, and they go up exponentially. So it's like something's gonna catch on fire with that.
Next time you shop for NPN, try to get packages that come with the insulators.
Thanks, Mike. I'm gonna do that.
Usually you have to buy the insulators separate, so get them together. Yeah.
So is it gonna be hard for me to find those? The ones that are insulated already? Or are they on Amazon and I just gotta pay a little bit more money?
Not at all. They're good. They're everywhere.
All right, nice. But yeah, we should have been doing that the whole time.
That's another tool in the tool belt.
Nice.
And he did mention that before.
Yeah.
No, they don't come insulated. You have to put the insulator on yourself. My bad.
Oh.
So
Yeah,
it's like a glove, like a sleeve kind of thing.
Can that stuff touch the other pins? There's no way I'm going to be able to do that if I can only touch the middle pin.
Like a piece of thin plastic. Yeah, okay. I can help.
All right, cool, man.
Paige can help too. She's probably a lot more still than I am.
That is so neat. Wow, dude. You're making me sick, man.
The transparent ones are mica. They come in ceramic also.
80. Holy cow. 83 volts. Wow.
Ceramic mica is the same thing.
Keep this stuff out of the fan. The fan's in that. Alright. So, have a little bit of fun.
He's like, yeah, I wasn't using the insulator either. It was a hard lesson.
Wow, we're like 1.941. Still under 2 watts. 91, dang, 91 DC volt. These are DC volts. And I'm hoping that the coil that I'm making right now is going to trump that. So neat. How
Yeah.
something, yeah.
We made a short making that spiral. It's pretty cool.
Something so small here can like just do that. That's awesome.
Yeah.
97 volts. Can we get 100 DC volts out of this coil? I think yes. I think we're going to do it relatively soon. 100 out with less than 2 watts in. How can we test the amps for this coil?
Once you have the insulator, you can test the heat with your finger, no problems. Okay.
Sounds good. So, how do you apply it? Is it just a Q-tip or something?
They sell different types of insulators shaped for each transistor, and it fits right on.
Oh, like a glove. Gotcha.
Some come with holes if you're using 3055. Two and 3055.
Awesome.
Yeah, I feel wind.
Yep, we're already back on. I turned it to amps and it just put a load on it, so I turned it back on to testing voltage and we're already back up to where we were. Just removing that switch a little bit.
Yeah, Mike says you can hear the new transistor in this spin. You can hear it.
Heck yeah.
Says,
100 volts.
good to go, Bale.
All right, Mike. So what do you think? Can I use this coil here to make this work? Just without any power going through it? Just wrapping it the right way, having it to its own power, and make this move.
It says don't touch the collector until you insulate it.
Alright, so you saying I should hook a transistor up to the little wheel? Trying to use this coil right here to be a power supply for this wheel right here.
Yeah, the little wheel, yep. And the fat coil. Nah, just use the mags on the big wheel to spin the mags on the small wheel.
Alright, let me see what that's all about. Can't get this off of here right now. I'll work on it. And then once I have it put on a free shaft, I'll give that a shot. But I think I'm going to need to take some magnets off of this to make that work. Make it work well, I mean. Like it had to be 6 magnets instead of 12.
You may be able to spin it with the other pole of your drive coil, the back of it.
Right here, this one.
Yep, the drive coil. Yeah. Ooh, we got a cross.
No, that was me destroying the thing.
Oh, okay. Woo!
Alright. See, there you go. I forgot to turn the power off.
Is the little coil the drive or the trigger?
This one?
Is that one or that one?
This one's the drive.
Okay.
And I'm using a Hall effect sensor. I'm not using a trigger coil.
Okay, got it.
Alright, so. That'd be really interesting if that actually works. I'm probably gonna have to swap out the transistors though.
So the big coil is DC out.
DCL.
Nice one. He's like, well, he's like, got it. Yeah. He likes to do things one-handed. It makes sense. It's like you deal with what's in front of you.
No, it's because I utilize every space, every surface inch, everything. It's all utilized.
Nice. I like it.
That's not close enough though. Now we got all these extra wires. Get this off here.
That's a 3D printed block.
And right now it's currently stuck on that shaft and need to get some tools to get it off real quick.
And that's the same one right there. It was multicolored filament.
Oh yeah. believe it's just the cross wires. All right, we're gonna have to switch. No, that looks like it's working just fine, actually. No, maybe not.
If you ever look at or get into three-phase stator power, you're going to like what you find. Peter Hall-Effect 2.0. What up, Papa Bale?
What's up, man? How's it going, Peter? We are exploring transistors at the moment. We're trying to use, right now, the drive coil to the back end of the drive coil to spin this little wheel.
Peter says, good brother.
All right.
Mike says, it combines well with DC pulse drive systems. And that's the three-phase stator power.
Okay. Heck yeah, that sounds neat. All right, so
Do you have a rectifier from Peter?
for which part of this? I have one in the series circuit here. I have one coming off this big coil here. But they're just diodes. They're not like bridge rectifiers. But where at? I mean, should we break the circuit down for you in order? Just so you can tell me where to put it. All right, we got the power supply. Comes here to the power distribution. And then it goes from here through the coil, out the coil, to the breadboard, and then to its respective base connection, and the emitter goes back to the ground. So
Mike says, did you see the links I posted?
previously, I think I did look at them.
He's like, maybe give me wrench. On my channel, I have a nice flyback circuit.
Oh, I did, yeah. Man, I look at that stuff all the time, and I got batteries on the way. I got off-on switches on the way, but that's just to try and get a better drive circuit. I want a good drive, but those batteries, hopefully, I'll be able to charge them.
All right, right after he sent that, he said with DPDT relay.
Oh yeah, yeah. I couldn't make heads or tail. Which schematic is this for? The flyback one? Yeah, I got those little diodes. I bought a pack of them. The ones you suggested that we used, like the N4001s or whatever.
And DPDT is double pull, double throw.
Okay. And what does that do exactly? Is that like
1N4007 HV diode.
4007? That's it.
DPDT switched two poles, aka positive negative.
Gotcha.
Double pull, double throw.
So that'd be like a parallel circuit almost, right?
Right now you are switching one pole.
Oh, for the north-south, you mean? Or just the axis? I'm trying to figure out what a pole is in regards to the lingo here.
Either the positive or the negative. Switching the source power to the circuit.
So the pole is either positive or negative. The source power to the circuit. Yeah. I mean, I get it a little bit. But we should definitely explore this more when my switches and the batteries get here, because then we can actually set it up, and we can build it.
I know what you could do in the meantime.
Right?
You could print one of these
Yeah.
that has holes around the edge too, so you can put shaft in there.
For the mini sculpture.
And then we can test this one too, so because it would be right here.
Yeah, we just take it out of the thing altogether. What we're gonna try and do.
Oh, no doubt. And while that's happening, we'll be 3D printing one of these that'll have holes in the center and around the edge. Because we want it to be fixed.
Yeah, when it's over there.
Yeah, and it might not go into a hole underneath here, but we should be able to print it thick enough to where it can be fine, you know what I mean?
Yeah, I get you.
All right, hold on, let me get back here. Mike does says most just switch either the positive or the negative. Okay. Peter says the big generator coil, the wires from it hook each end to the AC input on a rectifier. Then run two wires from the positive and negative off the rectifier to the cap.
To the cap. Okay. One of these bad boys right here, these super caps.
And my bad,
All good, dude.
that's it for experimental purposes. If we have any filament, I think that would be a good idea.
Gonna try and find one of those little square rectifiers real quick. Should be right. Yep, I got it.
Mike concurred with Pete. Pete said, then use the cap to power the circuit to the small pulse motor.
Just one cap?
Mike, excuse me, Mike says that's a field coil, no?
I don't know what that is. Yeah, it's a big coil. It's got 22,000 turns in it. It's a single file coil. This one, right?
Yeah. Yep. Like a car alternator setup. Okay, interesting. I didn't do the mechanic thing, but my friend would know all about that.
All right, I found it. So you're telling me,
Hold on. The coil should be putting off the most power because it has the most wires that cross with the lines of flux from the magnets. From Peter.
this one right here.
Yes.
Yeah, it
Yeah.
just,
Yeah.
it's the wrong dimensions in my mind because, well, the one that I'm building right now is going to be perfect, like hammer to nail. Every fiber of that coil is going to be saturated, like it's going to be beautiful. But this one I think is just a little large for my rotor here. The rotor should be a little bit thicker than it is for that coil to be optimal.
And that's a 14-inch. Are you talking top to bottom
Top
thicker?
to bottom.
Okay.
Yeah.
Got it. Let me try to get a close up. A little further in. There we go.
Now we're just hooking it directly to the cap, right?
Right, the output of the rectifier is your DC. To the AC sides, then the DC sides to the cap. Mike says, assume the big coil is making AC even though it's monopole mags on the rotor.
Yep. Yeah, I always do that now. That electricity that comes out the ass end of the coil is AC.
All right.
Alright, so now we just need to stop this. I don't want to get my hair singed. Alright, so this.
Excuse me.
Is positive. So it's positive to positive, yes? Positive, positive. Good deal, thank you.
Yes!
Yay! Alright, and then this one goes back to the other end of the rectifier, correct? The negative side?
Yes.
But alright, now this is where I am questioning this. This is a 2.7 volt, 500 farad capacitor. And this thing's generating like 105 DC volts. Does that matter?
Next, put a voltmeter to the cap and see the power.
Alright, so so we want
And
to
then
put the multimeter on the cap.
Yep, and then Mike says Bale has the flyback in his head. That's what's confusing. Forget about the flyback until you're ready to capture it. Paige just came in with some Russian. What up, Paige?
What up, baby?
Peter says it will be a great. Yep. And that was to next put a voltmeter to the cap and see the power. And there's the voltmeter hooked up. Let me get a good shot of that without the glare. There we go. When you turn it back on, watch the power go up on the cap.
So we're at -1 right now.
Let's see if I can capture that. There it is. There's it. From the AC, from that, get that thing spinning. There it goes. Just starting up.
I must have the clips hooked on the cap wrong. Or not have something hooked up, but something's not right because it's -1 and it's not moving at all.
The rectifier power from that coil should fill up the cap. Yes.
So it's not going to burst until the cap's full or what?
And then let's look at that. That's what it looks like now. Meter set to DC.
Yes.
It will only hold so much power. Meter set to DC, so we're looking at the wrong thing.
So it has to be set to AC. It's still 0. That's not right.
And there's the cap again. DC. Explanation.
Yeah, it was on DC.
Set to DC is correct. Yep. So that's just a chat lag thing and my misunderstanding. The leads on the voltmeter are hooked to the cap, right?
I don't know what that means.
These
Yeah, of course those are right.
are hooked to the cap. Okay.
So this is the positive. No,
Aha.
that makes sense.
Make sure the two ends of the big coil are on the input of the rectifier, not the output.
There it is.
There we go.
Man, hold on.
Rectifier has two input points labeled with this.
Yeah,
With a sine wave.
0.66. The way it is right now, and look at the voltage going in. Okay, back on that.
The output point are labeled with a plus sign and a minus sign.
Oh, yeah, I got it. They're right.
You got it. Yep.
Yeah, they're right.
Now turn it up, and we'll watch this. Sorry about the glare. There we go. Let's try to get them both. The faster it goes, the more power should fill that cap.
All right, these connections aren't going to work, I don't think.
Big caps take longer than small caps to show volt increase.
No, there's nothing happening here.
How many farad is the cap?
500.
500. No. Page like I wish I was there. Does the big coil have a core?
No.
And Peter's like, geez, okay. I wish. I was too. He said he wished he was here.
Yeah, that's cool.
500 farad will take 24 hours. So there is something happening. 500 microfarad.
No, it's not micro. 500F.
So then it should be more closer to an hour. No core, that's the issue. Put the big coil with its side facing the rotor.
Ah,
That's
yeah.
from Mike. And Peter says, okay, take the cap out of the equation because of it, because it's a 500.
Oh, I got a better one. It's different.
What's a recommended farad level?
We want here 2200 micro with a 10-volt capacity.
500 farad is too big. 100 MF is what you want. So you want to go, oh, you want to go even lower. So that's even bigger than this one. Wait, no. 22 MK is good.
Yeah.
Or my bad, 22 MF is good.
UF. Well, MF. Yeah. 10 volt. It's good. This one. Look at these ends, man. We'll be able to work with this. All right.
Good. Yep. All right, we'll look that one up. Run the DC power off the rectifier right into the input power to the small pulse motor. That's without a cap. That's from Peter.
Okay. Now, gotta get the coil back on there.
And Mike concurred with that.
You know,
And then
I
Mike's,
want something simple, not all 4-filer like that. Just a simple coil. What are you saying, bro?
And then Mike did say caps help, and he did recommend switching that on its side. And now we do have a 2200 MF. At least use the cap to verify your output, and that will happen when we do this. Correct.
Okay, what am I doing? It's changing this for that.
Yep.
All right, so there's the positive sign right there. Plus, it's the only one that's facing a different direction, correct?
There it is.
That'll go to the negative. Now, we're hooking this up in series, or we're doing it parallel with the rectifier here?
Parallel.
Parallel. Okay.
Positive, positive, negative, negative.
Yeah. That's real important. Oh man, see, this is what I don't like. This in my mind is positive because it's all glowing and shiny and stuff. But you know, it's not. It's negative. It's negative is the outflow. Negative is where all the power goes.
That's the negative. Yep. Peter says, think of your rectifier as you would your power source.
Gotcha. All right. So now we gotta get a coil. But we can turn this on, right? And see if we get a result from the cap. Now that we hooked up right. Now to get a reading from this, do I hook it up again parallel, or are we hooking it up the opposite direction, north, or red to red? Oh, let's turn it on.
White stripe on the cap is negative.
All right, so that's negative power, so I should change them, right?
Yeah.
So that's parallel, that's negative to negative, and that's how you're supposed to do it, I'm guessing. Perfect.
Yep. All right. Now, let me just make sure there's no glare there. Oh. Sorry.
Oh, you're good. You're good. I'm just trying to help you. Yeah, all right. So now we got that. And now, since it's all hooked up parallel, we can look at these two ends the same as the two ends from the rectifier.
And then Mike says you're not doing flyback right now, so parallels. Positive, positive, negative, negative on everything.
Well, unless you're doing it in series, and then you go positive to negative in a straight line, you know?
Okay, so from what you're trying to do, trying to capture the magnetic field
Right.
from the rotor,
Parallel.
is the best way to capture it. Yep.
All right. So, see, that might have been what some of the problem was all along. I was just trying to do it the way that I know. But, you know, parallel's always been difficult for me. I've never got it to work the way I think it should, except for just recently. In the last couple of years, well, actually the last year only.
With the meter connected and the small cap, you can move the coil around to find the best position.
So, what style coil do you guys recommend? I've got 20 gauge. That'll be real responsive.
Highest voltage. So I thought he was talking about this one.
What did he say?
Just moving that one around to find the best position. Am I correct, or did you say put a new coil in there?
Is this about the one over here?
Oh, my bad. So we're focusing on this little wheel, guys. I'm trying to spin that one. That's right. I am on a different planet. I'm sorry.
No, you're not. So, I mean, like...
All right. Mike says, for the power generation, I recommend S-phase stator and north-south rotor mags. The power coil for the small PM comes from Peter. And then use a 26-ish.
26? I got tons of that.
Three-phase stator from Mike.
Yeah, Mike, we're going to have to work with what we got right now.
Okay.
Unless you got a way to explain that to me in a lot more detail, I don't know about that. But, I mean, I don't know. I mean, I do understand, like, three phases, like, if you did three 120-degree circuits and had them separately, but working together through timing, I could see that as being something we could do. That would take weeks for me to complete.
120 degrees, correct.
But that's just one phase. Right? And do I not know what a phase is? And that's totally possible.
Mags on face of the same rotor you have now. and keep spinning it with the circumference mags. So a new coil can go like right here, you're saying? Right up on it. Place 3-phase stator on face mags. Hi, Lim. We have
Hey, what's up, Lim?
Peter says yes. Yep.
So these are all facing the same direction. So that's one thing we're going to be working with right now. That these are all facing the same direction.
Right, and then yeah, coil will need to go right here or near close to
And
it.
that's what I'm trying to discuss with everybody. Should we use 2026?
26 is yep.
He said 26. That feels good to me somehow. Now,
He says that's a good end goal for the system you're trying to build.
what is?
Hold on. Oh, 3-phase stator on the face mags.
Ah, gotcha.
Okay. Yeah.
Yeah, I think I've gone there a couple times. I've actually got 9 coils involved with it.
And then Peter says the drive coil, hook it up to the circuit that is powered from the rectifier.
All right.
Mike says DC pulse drive with the 3-phase stator, so that we'll look that one up for sure, and we'll look on your channel for sure.
Absolutely.
And then we got rectify the 3-phase for your DC power to the DC pulse system. We got Sonny saying, "Chris, I know where you live." And we got Paige saying, "Sonny is my friend."
What's up, Sonny? All right, so we're gonna use this little beast right here. Gonna find an end to one of the 26 gauge strands here. This is a 50 turn coil, so I mean we're gonna try and shove all that electricity.
Peter's like, "Bro, I had to get the same power supply you got. This thing is awesome."
Heck yeah, heck yeah, dude! All the way, man. I seen your pulse motor that you made with the can and everything. That's awesome. That's really cool.
Don't worry about it, Paige. It's Sonny. Don't worry about it.
All right, so this is with the coil.
Video is called DC Power Supply on Mike's channel.
Awesome. We have a problem. Oh no, that's the capacitor.
Peter says, "Thanks. I like your 3D printed rotors."
Thanks, man. I mean, this is how we were doing it. And this thing is still badass, man. It is still the bomb.
Oh, the original.
This is how we were working it. This is a bunch of wooden discs glued together that weren't warped. Like the only 5 that weren't warped in the whole pack. And like it moves. 1,000 videos were made on this.
Yeah. Wow. It's called the poor man's desulfator circuit, but you can also use that circuit as a DC PS.
All right, so we're gonna use. Where did I put it? I want to use one that's already on its own little pedestal though, because I don't
Yeah, that's I didn't know what that meant. That PS is for power supply. Sorry, hold on. All right, chiropractor.
Swap this one out.
Don't worry about it.
Yeah, this little master ring right here. If it's right on the ring like that. This thing's got some kick to it though. It's not a joke. It's actually pretty funny, but I mean,
All right, got it, Mike.
what's up, Mike?
He's teaching me the abbreviations.
All right. Good, good. Oh no, we don't want to put that on this.
Ultra high frequency. Yep,
We want to
got
put
it.
them on that correctly. Dang it. Just thought it was so high, like,
Quad filer.
Hmm?
Did you know that our eyes cannot see infrared? I did know that, but I think that we're going to have some kind of tech that it will allow us to see it if we want.
All right. So
That's right.
this is gonna stop everything, so we might as well just turn it off. I'm gonna do. Well, no, it won't. Gotta quickly connect this side to the other side.
Nice. Nibiru is infrared.
Here it is.
When I was in Laguna Beach in 2021, like the sun was setting over the ocean, and right as it crested, there was this giant green flash that shot right out of the top of the sun. It was awesome.
Now, are we going straight from the cap to the coil, or are we going straight from the rectifier to the coil? We're having the cap be charged on the off side here, because I can I can either hook the cables here.
Rectifier.
Okay. All right. Yeah. Rectifier.
The delay's not too bad. It's about 10 seconds, maybe 12.
All right. So positive. And usually the positive for me is the start of the coil, which I don't know which one it is here. Oh yeah, I do. It's this one. I usually put tape on it, saying which side is what. And because if they all do that, then you can line up a bunch of them and they'll all be doing the same thing. So I mean, it's kind of important when doing some things.
With electricity flowing.
Who said that?
Someone that knows about electricity.
That's not what I asked.
Don't hook the rectifier directly to the coil. Make sure it's hooked up to the pulse circuit.
What are you talking about? I don't know what you mean. I mean, we got to this point, and then we're here, and then it's like, don't do that. So what are we? What are
The
we doing?
DC from the rectifier.
All right, bro. Are you relaying well?
There's a delay, so you just have to
Wait.
make sure that you're
I don't know what I'm doing, so I'm
plug it
gonna
in.
wait.
So ask the question again, and then we'll wait.
Okay, like what I have in front of me, what do I do next? Okay, we got this that was hooked, and now I'm hooking. We got the capacitor hooked to the rectifier, and then we got the coil now being hooked to the rectifier, and somebody's saying that's right, and somebody's saying that's wrong. Probably all wrong. You know, not what you guys are telling me. Just this could be a lot different. You know, if I not just started earlier, but had like the proper training. You know.
You're good. This is what it is. This is the proper training right here.
Yeah.
Okay. Mike says coil goes input of rectifier and cap goes output of rectifier.
So that's series, right? Series. Input of rectifier. So I should disconnect the cap now from the rectifier, the way it's hooked up parallel.
And then from there you hook up your meter. So coil goes input of rectifier and cap goes output of rectifier. From there you hook up your meter. Peter says no.
Okay. So why don't we do
Cap goes to the pulse and minus symbol, plus and minus symbol.
yeah,
Sorry, go ahead.
That's good.
Coil goes to the sine wave symbol. You know the sine wave symbol?
I have no idea what that is or where it is.
I bet it would be on here. So is this
All
charged?
those are like
Act live right now?
it's not the fact that they're on, it's just let's look. The plus symbol and the other ones are AC. So this is the positive right here. The one that's different than every other one.
And there's no other markings on either side?
No.
2 are in, 2 are out. Rectifier has 4 terminals. 2 in, 2 out.
There are 2 to the coil and a positive and a negative to the cap. 2 in, 2 out. So now what I'm saying is, do we hook it from a rectifier, leave the cap the way it is, and hook it parallel to the coil, or we hook it and redo the whole circuit now that we're going to hook the coil up in there? So what I'm going to do is I'm going to now hook the negative. I'm pretty sure that if all, maybe I'm wrong about that. I used to think that they could all be AC in, the ones that weren't, that were all facing the same direction. But that doesn't seem right.
You need to make sure there's your drive circuit to drive the little coil that drives the rotor. And then Mike says the other 2 points that are left is your input AC from the coil.
That they're all used.
Okay, here it is. 180 degrees from the plus sign is the negative sign.
Right. They're all hooked up.
So you got it. You got it hooked up.
They're all ready to go. All right, we're gonna just give it a quick rundown here. We got this cap in the middle, basically, of a circuit that goes from the coil in these two. It doesn't matter whether one's sucking or one's pulling. Both ends of the coil are connected to the bridge rectifier. Then the positive is connected to the cap. It's also connected to the coil, parallel, with the negative, which is also connected to the coil and to the cap. So it's going to be doing both those things simultaneously, I would hope.
All right, you should get 0.7 ohms across the 4 diodes in the rectifier, if it's working right.
All right, I don't have the little needle things to do that with, so.
It needs a drive circuit.
This needs a drive circuit.
Right.
So it needs like a switch, right?
You can't just hook up the coil. Meter on OHM setting. Yes, yes.
How much? How many ohms? 200? We'll do 200.
$200.
You know what? We need to find my other one. I'm not testing, I'm not doing this with clips, man. I'm not doing that.
All right, now I got about 10 more minutes.
Shit's way too much to even think about it. But I do have another.
Mike says put it on 10 ohms or less.
There's no setting for 10 ohms.
No setting for 10 ohms. Here's the settings. Meter has diode setting for testing diodes.
I have no idea.
Papa's mind is blown.
Oh, I'm good. Do we hook a switch up to it? I mean, I don't need to do all that testing right now. Just let's move forward.
Image of a diode printed on the meter.
Right here.
The image of a diode symbol right there. Got it.
Got it. So that'll go 10 or below?
In the ohm setting, yes. Okay, from Peter. Yes, that small coil for the small rotor needs a switching device to turn the wheel. From Mike, now check the rectifier.
All right. And that's 0.7?
Yep, 0.7 ohms. He said 0.5 ohms. No.
All right. And that's. Not doing it right, I don't think.
That looked like point in between. 0.46. We're almost to 0.5.
No, it's not going to get there. Now, these are. Well, let's clip it on there.
You can't have anything hooked to the rectifier.
Okay. That's okay.
Oh, that's checking to see if it's good. Got it.
Man, bro.
Bro.
I'm laughing. Pretty sure this will give us a good reading.
Close. Very close. Nice rectifiers, by the way. Those are high voltage ones. They'll last forever. That's one diode. You have 3 left to check.
I don't know what you're talking about.
So check each one of those.
I did. What do you mean?
So he doesn't know what you're talking about.
This is, no, that's not how I check this thing. What do you mean like this? But it's got no. One of them was working, the out one, or, no, I got that on the wrong thing there. All right, positive, and let's see. Positive and negative.
There we go.
Yeah, it's only doing the negative and the positive. So, there, it's done. I thought we were talking about different diodes here.
All right, we're going to get ready to wrap it up here, guys. You have 8 polarity to check.
No, I'll check it the old-fashioned way.
Because you can't read the rectifier. It has no diagram. One of the 2 polarity will give you 0.5 ohm. Okay.
I think 0.48 is good enough.
Yeah. Oh, for sure. Peter. This is all very helpful. Can't wait for other people to be throwing input in at the same time.
What's going on after I get to look at everything here. So I'm getting relayed. It's doing pretty good, but I don't know. We need a monitor up here on the wall so I can see what's going on. All right, so these are the 2 ends of the coil connected here. This is the negative of the rectifier to the negative of the cap.
Peter's like, I'm from, I think that's either Missouri or Montana. I can't. M.O. Montana.
Pretty sure. I don't know.
Missouri, yeah.
That makes sense. But I would get that wrong.
Well, me too. And we're from Detroit, and we don't know how to fix cars.
Right on, B. Alright. So now we do a series circuit with a switch in it and connect it up to the, depending on where we draw the circuit from, back up to the rectifier or the cap. I think we should use the cap. Can we use it hooked up parallel real quick?
See you later, Mike.
See you, Mike.
Peter's taking off too.
Bye,
See you later, Peter. Oh, he's chilling. He's staying. All right, ask the question one more time, bro.
Yeah, I was just wondering, do we hook up from series, we're gonna do a series because we gotta put the switch and the coil in together. From the cap here, or from the rectifier, or do we hook the rectifier and the cap now together in series through the coil and the switch? We got 1, 2, 3 options. I see.
I'd take the cap out.
Take it out.
Yeah.
All right. Sweet. All right. So now we go from our positive terminal and feed to the coil. Switch.
And hook it up just like you did the circuit that's driving your mother rotor.
With the Hall effect, then I need the transistors.
And the battery warning just came on.
Okay. All right. So one more time, I need to.
Yeah, just duplicate what you did here. Sounds like, right?
Yeah, I got a transistor in there.
Okay. Make a twin circuit to drive the little rotor. Yes.
Yes. Okay. Gotcha. The Hall effect sensor was over here. Yeah, it's right there on the ground. Oh, yeah, we gotta. I have to organize. All right. So,
All right. 4 minutes.
4 minutos. Well, I think this is gonna work. I think it's gonna be all right. Once I get like a transistor in there, I don't think that the electricity being generated the frequencies don't match. The needed frequency and the frequencies being generated by the pulse motor don't match. These don't match. They should match because they're both 12 magnets at both the same degrees. They should match, somewhere down the line. And that's what we're trying to find out, where that is.
3 minutes.
Okay, yeah, I'm not going to get this in there in time.
All right, let's wrap it up.
That's what I'm doing. All right. So, in conclusion, we've come a long way today, I think, from having everything hooked up the way it's supposed to be. And I think we're going to get this to move tonight.
And we'll make a video and we'll publish it on the channel.
All right, thank you very much. I'm kind of exhausted.
You did good, dude. You were getting feedback from 2 angles at the same time. That's you did good.
All right.
With the delay. This has been a blast. You will, buddy.
All right. Thank you, Peter.
You'll get this done. I know it works. Heck
Yeah,
yeah.
I believe you.
Mhm.
I mean, you're making stuff work out of cans, dude. That's pretty cool.
Yeah.
All right. Yeah. So, thank you. Peace out.
Bye-bye for now.